Thanks. So thank you so much for the opportunity. So I know we are between the break and us and all of that, so I'm going to try to accelerate this, and I'm hoping that this can be a little bit more interactive than just one-way street. So please do interrupt me if you want to ask questions and all of that. Let me start with telling you that my goal here is really to promote disaggregation, also encourage you to join some of these open source communities such as ONF, ORAN, and whatever community that there is. And in addition to that, I basically want to talk about some of the, how maybe LTE was more of an evolution and maybe 5G should be a revolution instead. With that, I maybe want to tell you that historically, we had this artificial walls between us and ODMs and OEMs, and so we were only talking to OEMs, and OEMs were talking to ODMs and IC vendors. And that has been really changing. It's been really evolving, past many years of discussions, us and the chip companies, us and the IP companies. We're sort of creating this multiple path to innovation where we don't necessarily have to wait for the OEMs to tell us or provide us, solutions, et cetera. And with that, I think I'm encouraging all of us to speed up some of the innovation around 5G, some of these open reference platforms, and some of the disruptive network connectivity that is really about having a better, faster, flexible, more elastic, and maybe with services that could be as part of the edge cloud stories and all of that. Some of the edge cloud-centric operating models, I think I'm not going to go over them, but really we are talking about deployment around modular capabilities, white boxes, and open source platforms. We are talking about economically viable ecosystem that enables machine learning AI and provides predictive and scenario-driven with microservices in place. It really, all of what we are talking about here is empowering the end customers, right? The end users, seamless data sharing, providing them with a better observability, increasing more of a trust and transparency, enabling some human and machine, basically collaboration, and of course cost and operation, better zero-touch operation, which Wisdom has been really discussed for many years inside AT&T. Going forward, I guess I want to sort of give you a little bit of a background in terms of the rise of Open RAN and why unified software-defined RAN is important for the 5G and beyond. If you look at some of where we came from with the 3GPP release 8 all the way to release 15, and now 15 plus and release 16 next year, we've been sort of on this evolution path, and it's been taking this many years to get where we are today. Right? With 5G release 15 plus, it seems that's where I'm hoping that revolution could happen, and we could innovate much faster and being able to be much more agile introducing services going forward. So it is nothing surprise that 5G is about a lot more spectrum, both in sub-6 gigahertz and millimeter wave. And so we need to sort of address both of them with respect to that. Each of them have their own path, and with beamforming at the heart of millimeter wave right now, but eventually beamforming and massive MIMO could also come to sub-6 gigahertz, and basically providing a technology and radio interfaces that we don't have today that could really evolve us from where we were with the distributed RAN towards more of a centralized RAN. And now we are going slowly towards virtualized RAN and EPC, and eventually this software-defined RAN, which is nothing but what ORAN is bringing to the table. And ONF and XRAN have been involved for a while, and we've been talking from SoftRAN days of Sachin Katti from Stanford, where we've been discussing ways to adopt that, and I think ONF have adopted the XRAN APIs already. We have demonstrated some of that in that sense. So I think the goal here is now how do we get to this open platform with these democratized interfaces, and probably what does democratized interfaces means. But before we talked about that, we understand that with 5G, with densification, et cetera, we have basically coexistence that sort of allows two or more systems to operate with least impact on each other. These are coexistence of radios, and cohesively we can look at the total amount of resources that we have between these radios. And a centralized approach with the software-defined RAN is looking at collaborative environment of how you can assign these frequencies and basically power and bandwidth associated with these radios. Or these radios can talk to each other and decide and do interference mitigation and so on. So with sharing of a common spectrum resources, especially if it is proactive and coordinated, we can really boost the system capacity. And the coordination comes from really software-defined RAN, where it has an airplane view of the radios, and it can involve multiple tiers of priority of access sharing, and we can, with some benefits of some form of a synchronization, we can decide how end users or applications are behaving. Can we put pack pressure on them? Can we enable them for being actually more of a network aware, not to be blind to the network, and vice versa, network not to be blind to the applications in that sense. This is more of a, we are sort of questioning if does unified air interface help with the coexistence of these different services, right? Where we are talking about, of course, very IoT-centric to even non-terrestrial access networks, such as maybe base stations on the drones, or even with next generation release 16 plus, where we need to actually, we're talking about some of these MEC services and edge clouds, vehicle, V2X type models, in a sense. Now, I took these slides from ONF. Oz probably was the first initiator, but I did modify it a little bit. If you look at it from the user control plane perspective and the control plane perspective, we're sort of saying, what can we do in terms of separation? What kind of control can we bring to the software-defined RAN? And what kind of user plane of the radio can it be controlled? Can we even control the user plane functions, MAC, PHY, beam patterns, in terms of schedulers and all of that, using the software-defined RAN perspective? And what I have on the right side is some of the ORAN-centric interfaces like A1, E2, and sort of trying to map that to what we need to do. When it comes to RAN slicing, for example, we need to control that over this E2 interface that ORAN defines. By the way, if you're not familiar with that, and if you go to xran.org, or if you, I'm sure you probably should be able to get access to some of that xran architectures that are white papers and all of that, and they are there. So I'm sort of showing that, okay, now let's do a separation of control from the user plane, and then what really gets control over what interface, and can we meet those demands. So in terms of rise of ORAN now, with ORAN, we talked about Open Radio Access Network, and how they are really complementing what 3GPP is bringing to the table in terms of standards and all of that. What are the common control configuration for the split architecture? How do we dynamically provide the split options that they exist within the 3GPP? How do we extend the control of configuration options to the vendor-specific features that they might bring to the table? We want to make sure that we have a default set of plugins that the vendors are going to adopt, and if they have extensions, how do we really adopt those extensions, those specific features, and all of that. Some of the measurements and configuration controls and all of that, I think I just want to remind you of. This is really what we need to control in terms of observability, scheduling the slices, controlling the admission control, doing the load balancing functions, doing some measurements, especially when it comes to radio resource control. Observability becomes important as an embedded part of the user plane function, not necessarily an overlay network and all of that. So what Open Reference Platform really offers, of course, it offers a new user experience in terms of what we like to do with the AR, VR, battery lives, and especially if we can do some of those functions at the edge instead of pushing it to the end devices. We want to provide for a new types of connectivity services, obviously. And I purposely put that in red because really that's what I want to talk about next. And of course, some of the feature functions that we've been talking about in terms of automation and perform frequent control across the LAN. These are close feedback loops that we need to establish in sub-seconds and maybe even sub few hundred millisecond options that we want to be able to provide a better basically RAN optimization going forward and all of that. So this I think leads us to adaptive analytics for 5G with open reference platform. I'm emphasizing on dynamic analytics and providing some of what we're trying to all achieve, which is really maximizing the throughput, bigger pipes, and reconfigurable dynamic pipes, and better and faster. We need to provide embedded or inline network telemetry. That's what P4 conceptually uses. We need to bring that to the radios. And in fact, I was just talking to Andy from one of the P4 designers today to see how we can achieve that, and we're going to have a follow-up on that, how we can do embedded inline radio observability, per se. Okay, so let's move on to basically a reference options, right? In terms of, I know you guys have seen a lot of core type architecture, spine and leaf, and axes and core functions on the other side of the spine and leaf. And this is more of an imaginary a control plane that where we have the axis, which is the RAN, and we have the core, and of course we have the MEC, which is all next to each other. All of these are service chained from the control plane. And this open reference platform that M-Core or software-defined RAN potentially can bring to a table or is bringing to a table is all about abstracting what's going on the RAN, core, and MEC services. And specifically, when it comes to RAN abstraction, I think we need to think about 5G terminologies, the slices, the beam patterns, and so on. Okay, so going forward in terms of the open source, basically communities and standards, now we are saying that how do we achieve that without 3GPP? And I believe that we are not going to do it without 3GPP. 3GPP still will specifically provide the standards and all of that. What if we certify them on the open reference platforms that we basically embrace, such as what we are doing here with M-Core activities and all of that. And sort of, I'm just trying to say that activities that we are doing with ONF and with ORAN, et cetera, they're just going to complement the standard bodies for some time to come. And so what are the opportunities? This is another slide from ONF, which really talks about everything is really a controller environment. Everything has its own control. The SDN has its own control, the control application, and VNFs, and basically the infrastructure as a service and all of that. They have their own control. And these logical controls form basically a bigger controller environment that we can achieve a better environment for authoritative states and the mediated trust and enforcement policies. And that comes with activating the data path and so on. So one of the challenges with 5G, I think, has been how do we abstract the topology, right? This is 5G talks about these radio units that gets attached to these distributed units, and then how it gets attached to these central units, et cetera. Now, the picture on the left here is a little bit sort of a standard, basically topology 101 type environment. But the question is now, if we want to really graph abstract the links or the slices or maybe a set of radio resources and all of that, we sort of need to basically think about graph abstraction, where the applications, if we want them to be vendor agnostics, they're programming these graph. And that's really what SDN brings to the table. And the goal of this challenge, that's where actually we are slowly going through that. ONF have already implemented the XRAN abstraction, but we might need more than that because of the beamforming, because of the slicing mechanisms, and so on. And the goal is really to understand those principles behind the abstractions, and how do we enable that and bring those, basically this multi-tenancy to the table, where I have, and a slice 1 is not interfering with a slice 2 or a slice n, and there is some privacy and control over that. So let me talk to you a little bit about this. Probably this picture is obvious to you guys also. This must be O's picture as well, where he's showing that the radio resource controller, RRC, is basically using XRAN APIs to control the stack, the RAN stack, the PHY, the MAC, the RRC, and PDPC. And if we adopt these APIs, then it's easier for us to do variations of what 5G is demanding from us in terms of the massive MIMO capabilities, the MAC, the multiple schedulers that potentially could be running on the MAC, and provide these controls using these. And also in addition to that, the observability that we can achieve for purpose of handoff management, admission control, and link aggregation, both at PDPC and maybe MAC layer, and sort of multiple schedulers that can provide the slices on us on the MAC layer levels. And aggregation of different kind of frequencies and MAC functions that we might provide for carrier aggregation and so on. All right, here is sort of an example of SDN RAN and microservices environment. So if we have this virtualized RAN and microservices that can run in COTS environment, or we can run in white box RUs and DUs. By RU, I mean radio unit and distributed unit that might be closer to the towers. Then we basically have this local RAN agents that could be localized, and that's where we could have some control at the local level, where the radios and maybe distributed units are. And as we move up to the software-defined RAN, such as MCORD, et cetera, we're providing additional radio resource abstraction graph for purpose of some of those applications, such as mobility policy, carrier aggregation, and virtual RAN applications, and all of that. And of course, SD-RAN would also communicate with the master orchestrators, such as ONF, that we all know about. Okay, so this is an example of really, we talked a little bit about observability and all of that. This is an example of what we did for at least providing a in-band network telemetry or anomaly detection on a dynamic basis, where we were able to provide active testing from the vRAN controller or vRAN probe management entity, and only get the observability that we want from the environment as needed basis. So with the vRAN software platform, basically a model-driven passive monitoring becomes important, meaning that I'm going to model only what I need based on some conditions and thresholds and all of that. And based on that, I should be able to do anomaly detections and closed-loop automation, rather than waiting for all the data to come up from these eNode Bs, and then 15 minutes later create this open feedback loop, per se. Okay, and of course, active testing was part of that demo that we demonstrated with, of course, switches, but here now we are trying to do it with the radios, and I think at ONF, they did demonstrate that getting some information out of the radio quality of service for a UE, and then it would go back up to the master controller asking for more resources per that. So let me summarize and then maybe open it up to questions if you guys want to discuss this further and all of that. Aggressive spectrum allocation for 5G, which is really what we are doing by providing a lot more bandwidth and beyond. It really requires this unified and open democratized interfaces. And by that, I mean the traditional interfaces that we have today, even though they are open CPRI and all of that, they're really closed. They're proprietary. We still have to be, we cannot certify multi-vendor environment. And this is one thing we have to solve very quickly, both at the CPRI level and other interfaces. Opening up the interfaces in terms of disaggregating the RAN stack such that we can have maybe personalized scheduler functions and all of that. And we should be able to enable white box deployment models with coexistence of having these multiple vendor radios, et cetera, that they can coexist together. And we should be our key focus really as we move towards open source community standardization bodies. ORAN could, I think, provide a good coordinated and, when feasible, some synchronization for multi-vendor environment. And with a white box solution, that's where we are hoping to go. And last but not least is 5G really needs machine learning to do this zero-touch operation. We are more and more relying on learning or predicting or understanding of what is the fastest way to get to the steady state for our scheduling functions, for some of the applications that run and all of that. So I believe really, in-band radio analytics may be at the heart of this machine learning that we have to expose and all of that. So with that, I'm going to thank you for your time, and then let's see if there's a few questions, and then we can expand. Go ahead, please, Margaret.
So how do you make sure the work here is compatible with what's going on in ONAP?
My personal bias,
especially with AT&T involved in both.
Yeah. ONAP, I think this ONAP is providing the master orchestration, right? Whatever that happens at the software-defined RAN is not done in vacuum. The models, the description, the intent, and all of that comes from the policy and all of that will be executed at this software-defined RAN from whatever master orchestration. For AT&T is, of course, ONAP. For some other operator, maybe something else. Right? So we need to be able to take this policy and basically the intent that comes from ONAP and execute it and compile it into that.
But if you look at, I would summarize the biggest activity of a use case in ONAP is actually the 5G. They're defining everything, the PNFs, the VNFs. I'm not sure how they're reconciling that with the MEC activities. They're getting into the models. Mm-hmm. Right? They're getting to the data models, the information models. They're getting to very specific use cases on optimization, like PCI. There's something called PCI, I think, that you optimize in the I forget the terminology. I'm not a mobility person, but and the use cases are getting very specific. In fact, slicing is actually the next use case, right? So right? And VMAL, right? And AT&T's leading it.
So that's why. No, I'm very familiar with it. I think whatever we are doing here is not really in contrast with what ONAP is. ONAP is providing the configuration, the data models, etc. Here, what we have to do, we have to worry about this feedback loop control perspective. If we have to get really basically some of the slicing changes that we have to do adaptively, if you have to go all the way to ONAP and come back, it might be too late for certain applications.
Okay,
right?
so you're trying to say this would be more of a local domain, and then ONAP would be more at a higher level.
Higher up.
Because it's more than just orchestration, right? What's going on with ONAP?
Yeah.
Right. Well, the other thing I was going to add is based on how they're coming up with models for PNFs and VNFs, it's actually influencing the whole state of the world, I would say, even like network products of how you handle PNFs and VNFs. So I'm finding that the 5G use case in ONAP is actually influencing everybody. And that's why I was curious how you guys make sure you reconcile.
No, that's great. No, absolutely. So we've been talking a lot, to your point, a lot about, in terms of the slicing in addition to that beam pattern control and some of the ability to map that to scheduling function, QoS, and all of that. That requires tighter loops and all of that. And I think that's why the software-defined RAN becomes important. Anything else? Right, coffee is waiting for you guys. Oh, I'm sorry, you had another question.
Thanks for the presentation. I think I have a question regarding the model-driven monitoring that you mentioned.
Right. Deep observability and all of that.
Yeah, can you elaborate what elements are you collecting, or what's in the current stage and what's in the plan to what elements will be collected on that perspective? And second question would be on the services slicing you also mentioned on the IoT and the vehicle. So what data you will be collecting, or what has been tested on?
Okay. So let me address the first question. This observability, or basically this dynamic observability, becomes important. And historically, people who are designing these chipsets, the ASICs or the radios, equipment, etc., they are deciding what kind of counters they need, what kind of control registers they need, and all of that. And what happens is they collect those, and they say, if you want to get those information, here is my driver, call this driver, this API, and I give it to you, and all of that. And really, a lot of those collect data that might be collected by an ASIC designer or basically a hardware designer. A lot of it is not used today because we don't know what that means. By the time we get it, it may be too late, and all of that. What we need to do is think about what P4 model is. I'm not saying actually P4 for the radios yet, but I'm thinking that what in-band network telemetry is, you basically, the application or the P4 language, you're describing what kind of analytics you need for this path or for this user plane. Now, if we could get there in terms of adaptively providing those analytics and then basically saying, by the way, here is my observability basically description, the model, and then here is the APIs that I'm going to call to get it from you. And you compiled my model into your own targeted environment, whether it's FPGA or hardware or software or what have you. So that's that. Your second question was about slicing, right? What do we collect, for example, from the slice and all of that? So let's assume that we have, we want to dedicate, for example, part of the spectrum, to IoT, another part of the spectrum to the FirstNet, right? Another part of the spectrum to some other customers and all of that. So we have basically this default set of profiles that's saying slice 1 profile, slice 2, slice 3, just like Margaret described that what ONAP is describing for 5G perspective. Now, when it comes to actual elasticity of it, all of a sudden some emergency happens. We provide some 5% to FirstNet, let's say, or some IoT. But when the threshold goes up, then this policy have to change. We have to sort of say there is 10% above the threshold demand for IoT, and there is 5% for the. Somebody have to sort of decide how to provide this fairness among these multiple slices. And that comes from the software-defined RAN. And all the measurements that I want to collect, I should be able to say that, put it into a model. I want to measure the load, the congestion, the environment for zone that I'm supporting and all of that. And that enables me to manage my slices at the software-defined RAN level.
On the slicing, do you only slice by spectrum, or is it also within a spectrum? Are there
within a spectrum there is also multiple slices, right? You basically we actually demonstrated that. He could talk about it a little bit more. He walked out. We take basically a scheduler today that sits inside the base station, right? If you basically extract it out and put it into this software-defined RAN, and you could have multiple agents of a scheduler for each slice running on the MAC layer, right? And then you're basically telling each agent how much of a radio resource block they have, and their constituents or their devices that they are managing is of IMSIs or is IoT type or some kind of classification that we can provide. So each local scheduler is responsible gets so much radio resource blocks to do that.
Is that the analytics that you're talking about here?
I'm sorry, say again?
Is that the analytics you talked about in in-band radio analytics?
Well, I think this one I'm talking generically that today we have this overlay network for analytics, and it's very expensive to operators. Providing overlay network and collecting all these analytics and 15 minutes later be able to react to it is expensive and not doable. And what I'm talking about is in-band network telemetry is how can we change that? How can we, through these models, describing to the microservices what they need to collect and then when they should stop, right? So that's the intention.
Yeah, but is it used in scheduling, or is the intention to?
It is. I think we did implement something inside the scheduler that says measure the quality of experience, or and in terms of from the demand and compared to assignment that's getting, a UE is getting. I think Oz, I wish he was here, would explain that. But we just implemented as a demonstration that you can monitor a flow quality of experience. And then basically when we see that there is a degradation in the quality of experience, then we would go ask the boss, which is the software-defined RAN, or in this case, I think Oz went all the way to ONAP and asked ONAP, and the ONAP changed the policy that you should get more percentage of the policy.
It could be possible to use DL model. We can talk offline.
Sure, absolutely. All right. With that, thank you so much.